Alright guys, so kind of like the next level is really nothing different. What would you do with this problem here? Which one? So you have to multiply by the reciprocal. Cool. So you'd write it as 4/15 times 25/8. And then you attack it like normal. How do? I mean, we know this is what we do with numbers. We know this is how they act. So then you can do the 4 goes into the 8 twice. What goes into both of these? 5. Good. So 3 there. 5 there. So what do you end up with? Good. 5/6. So obviously, if they give you a problem like this, yeah, do the same thing. So it's nothing different. It's just a division problem. You flip the second dude, it becomes a multiplication problem. Nothing new.
Just an extra step.
So as we're doing this, we can flip the second dude, but we can also, how do you factor the top of this here? Yeah, it'll be P and P. These are off by 1, so it'll have to be 5 and 1. Good, the bigger one's got to be positive. And then how do you factor this guy? 10 to make 7. 5 and 2, 11, and they both have to be positive.
Now we just cancel out what we can.
Yeah, so what cancels out?
P plus 5.
P plus 5s.
To the P minus 1.
P minus 1s, because one's on the top, one's on the bottom.
And then would you simplify the P plus?
So what's left alive?
P plus 4.
So P plus 4 on the top.
Plus 2.
P plus 2 on the bottom. Now can you make this cancel that?
No, because they're
Hell
both
no.
part of addition.
You can't make that a 2, you can't, no. That's all you can do. The top has a P plus 4, the bottom has a P plus 2. They have nothing in common. That's as far as you can go. Cool. So that's really the same problem. So I could have started any problem we did already. I could have just started with division and then flip it and then done the same things we did. So if it's division, that very first step is flip it. Or else you're going to end up with too much crap at the end possibly, right? Things they're supposed to cancel and they won't because you never flipped that guy. So how are we doing there? Is that decent? So none of the procedures have changed. When you multiply or divide fractions, you do this. So this is actually, in a way, this is nothing new. But now we're just able to do those procedures when we have a bunch of variable expressions in there. Right? We still flip division to make it multiplication. We still cancel the common stuff. It's just that I can't see the common stuff as easily. They're not numbers. I got to actually take a minute and factor it so that I can go, oh, they both have this and they both have that. That's what I mean by the process doesn't care what's in there. They're fractions with variables, but masses, I don't care. You still cancel whatever's common once you factor it. Same process. You still flip the dude if you're dividing. Same process. Okay. So, a little preview. So that's 7-2. That's all there is in 7-2. And the only thing they can do to make it worse or to make it more difficult is to give you uglier factoring problems, longer stuff. They can give you 3 pieces like A over B times C over D times E over F, where you can cross cancel and factor all this stuff. That's all they can really do. So as long as you know your factoring method, you just attack each piece, factor, and then kill, whatever you can, and see who's left alive. So let me throw something at you and see what you guys think.
This is a preview.
This is a preview, yeah. Actually, 7.4. 7.3 we don't do. Okay. So those are almost the same problem, right? You with me? Those two, that one there and that one there. There's only one slight difference, and that's all it takes to make that second one a decent amount more difficult. Because, again, math doesn't care what the hell's in there. I basically have the addition of two fractions. Cool? And of course, before you can add fractions, you need common denominator. So on the first problem, do they have a common denominator?
Yes.
Common denominator. If you say that often enough, it gets a little freaky. Common denominator. Common denominator. I think it's been a long day for me. So what do you get when you add those together?
6 over n minus 1.
Good. 6 over n minus 1. Not 6 over n minus 1 squared somehow, right? It's 4 of these plus 2 of these is 6 of these. This one's kind of done. So what the hell do I do about this guy? Make a common denominator. The problem is, now you should know this, the first step in almost everything in this chapter, I already told you, the first step in almost all the stuff in the chapter involves factoring. Because the mistake people make is maybe they'll try to multiply by m. Do you see why they would try to do that? We multiply by m. What are they focusing on? This is m squared. But when you multiply, you can't just do it here. You got to, oh shit. Right? So that's not going to help me out. I've got to see what he's made of so I can see what he's missing. That's the whole idea. If I can see what m squared minus 1 has in it, I can see what this guy is missing. So of course, that's why we factor it, so we can see what goes into it. How do you factor m squared minus 1? Exactly. It's a little thank God problem. So what is he missing that he's got? M plus 1. So the awesome thing about this, I want you to realize, if you're able to factor, you can see the parts, you can see exactly what he's missing, and what do? You give it to him. He's missing it, so you give it to him. But if I do this, what do I better do at the same time?
Do it on top.
Do it on the top too, yeah, exactly. So overall, I just did nothing. Right, if I multiply top and bottom of a fraction, I haven't really changed anything, but now I've made the bottoms the same.
Why did you put the n plus 1 on the other side? Just to get, like, make them the same, but...
So right now, they don't have the same denominator, right?
Yeah.
But I can see now that I factored this guy, I can see what he's missing. He's got an m minus 1, and so does he.
So are you multiplying the other side by that? Is that what you just did? Okay.
Because what do I need? I need an n plus 1.
Okay.
So I multiply top and bottom by m plus 1.
Okay.
So then on the bottom, what are you going to get when you add these together? M minus 1, m plus 1. I like it. That's the LCD. That's the common denominator. What do you get up here?
4m plus 4.
Good. 4m plus 4 plus 2. So now you can put them together, right? Because now you made the bottoms the same. So now you can put that together with that because you've made the bottoms the same. It's the same process as before. Math doesn't care what the hell's in there. The process is the same. Make the denominators the same. Once you do it, you're allowed to put them together. So what do you get on the top then here at the end? 4m plus 6. Over that.
Same thing.
Why do you think you don't want to multiply the bottom out? Because what do you think the last step is? What's always the last step in a fraction problem? When you get an answer, you got to check and see if it
Adds up.
reduces. Right? If you get an answer of 6/8, and you give that to your teacher, they're not gonna be happy because it should be 3/4. So I leave this factor. Don't multiply this back out, because then if I can see easier if there's something that cancels. Is there anything that cancels?
Nope.
No, so I'm done. I can't reduce that fraction. So if you factor every bottom that you can, then you can see who's got what, who's missing what, and you give it to them. So really, let's take a step back. Let me show you actually with that problem I had up here a second ago. If I had to do 4/15 plus 8/25, here's one way to do this problem. What do these have in common? 5. So what's 15? 5 times 3. What's 25? 5 times 5. So what's he missing that he's got? 3. So you give him a 3. And what's he missing that he's got? Another 5. So you give him a 5. How are we doing so far? I mean, this is what you do. This is how you add fractions, right? You make both the bottoms the same. We can actually use that process to make uglier numbers easier to do. Factor them according to what they have in common, and then see what the hell they're missing. What will the bottom be now? It'll be 3/4 is 75. So the bottom is 75. And on the top I get 20 plus 24 is 44. Cool. I mean, that's how you do that, isn't it? No, okay. It's because what you normally do is you try to figure out directly. Well, it's easier to do this. Now, if you had something really easy like 1/3 plus 2/9, what's the LCD? Because that's 3 times 3, he's just missing a 3, right? So you give him what he's missing. If you give him what he's missing according to this guy, you've made them both the same. So we're not doing a different process. The process is the same. I want to make the bottoms the same. But how I get there is different, because I can't look at it as easily as I can numbers. Right? So I have to actually factor this out so I can see what the parts are. So this is made up of n minus 1 and n plus 1, so he's obviously missing an n plus 1. So that's really kind of nice. You just give the one that's missing something what he's missing, and then you're able to do something. Let's do one more of this. Let's see. So again, what's the very first step?
Factor the second.
Factor which one?
The bottom.
The bottom,
The big guy.
I like it. So you'll want to see what he's made of, so you can compare it to what the other guy has, and give him whatever he's missing. So how do you factor this guy? 9 and 4, plus 9, minus 4. So what's the other guy missing? A y plus 9. I like it. Now let me do this a certain way so you can see the big mistake people make. What's going to be on the bottom?
Y plus 9, y plus 4.
Now, if I just write this exactly the way it is, and actually one mistake you can make is you can do 3y plus 27 and forget that minus. Right? So very often I have a minus 3y and a plus 27, and really it should be a negative 27. You with me? So it's really easy to forget that negative. Sometimes I'll just tell people make it a plus negative, then you can't forget it. It's right there. You can always make minus a plus a negative, right? Okay, didn't like that way. That's all right. I'll take it away. But what do you think people do here that's a big mistake? The way that it's written.
Minus the three.
They
Cross those out. Are you allowed to do that? Hell no. The division cannot cancel part of a subtraction problem. It's really easy and it's only human. We don't like all that crap. Let me kill it. Right? But I can't. But the nice thing about doing this is you don't forget the negative. So on the top we'll get y minus 3 minus 3y minus 27. So I get minus 2y minus 30 over this business. Do you think anything's going to cancel? I could take a 2 out, but there would be a 15 left here. There's nothing down there like that, right? You guys see that? There's nothing that's going to cancel, because I could take a 2 out, but that would be a 15. There's no 15s here. There's no y plus 15 or anything. So that's it. That's as far as it goes. I cannot reduce this.
Oh, okay.
Intriguing, Jeff. All right, so that's actually a pretty decent preview there. So we should be able to finish it out next time. All right, and next time I'll have an updated homework sheet. Since obviously we're getting to crunch time, we're probably not going to be able to cover all the sections I had planned to. So I'll update the homework sheet for you next time. Okay. Yeah.